Welcome back to Remote Sensing 1 Winter Term 2020. This is an overview of week 7. We're getting along in the term. There is some time left, and things tend to pick up, I think, in terms of maybe the speed. It seems like things are moving pretty quickly at this point of the term. But we still have quite a bit left to do, and I think some very exciting things to do. So just let me review just quickly a little bit about last week. Last week we started working on activity 3, which is focused on the technique of supervised image classification. Image classification is probably the most difficult problem that we have to solve in remote sensing. And to that regard, it's something that there are a number of different approaches that have been taken, and supervised image classification is probably the most, I think you'd have to say, robust approach, I think, at least, because it does combine knowledge that experts like you have about particular places and fields of concern that we're interested in, so things and places, and it applies that and allows the analyst to interact with the system and really to train the system to use their expert knowledge, so that the system becomes an expert system using the knowledge that you have to train itself to solve that problem of taking these data that we have that are so complex, as I think I made clear, abundantly clear last week, are so complex, and reducing it to a very workable set of categories and classes that becomes more useful, more actionable. And these are classes that meet a particular criteria. And in our case, as remote sensors, the criteria that they meet are criteria of either emittance or reflectance, or how do they look, right? That's how you would put it in human terms, right? But to the machine, things look the way they do because of these measurements of reflectance and emittance that we take with our machines, with our satellites and our cameras and imaging devices, digital imaging devices. So we're working on supervised classification. I'm still working on activity 2. I want to get that done as quickly as I can, because I know this is probably the most important thing that we do. Certainly the most it's not the most important thing that we do, but certainly it is very important to get feedback back to you guys so that you understand what you've done and when you've done really well and so on, and so that you can learn from that experience. This week we are going to start looking at change analysis through image differencing. And I have what I think is a pretty strong presentation on that. I mean, I've looked this over a couple times. It is new. I've redone it recently, and I think it's a good reflection and a strong presentation on change analysis. Because we do tend to get smarter as we get older. This is a little secret all us old people have. But so I've reflected quite a lot on change analysis and what it means, and how it is certainly this technique that we have in remote sensing that gives us a lot of power in terms of being able to produce strong and convincing arguments for our time, right? Because change is an important, really important category for analysts to be analyzing right now, and this is something that we can do a very, very strong job on with remote sensing technology. We can answer, I think, some very important questions about the world and the people and the natural and physical environments that we live within. So we're going to be looking at image differencing. Don't miss this presentation that's in the content in week 7. It's I think it's a really good, strong presentation on change analysis. And we also have coming up at the end of this week 7, our final project proposals are due. And I hope I wasn't too harsh on you in the email that I sent out yesterday, I guess. Let me check yesterday. And this is something that the conversation with me is not optional. This is required. Okay. So we need to figure this out. And a conversation does not entail an email exchange. That doesn't meet the requirement, because I don't like sitting and typing emails back to people with all my thoughts about what you're thinking about doing. I'd rather have a conversation. We can exchange a lot more information more quickly. If we do it on Zoom, we can do it. I can do it with screen share, and maybe can show you some things, point some things out that could be useful, or we can explore together. With our computers. I mean, Zoom actually is working fairly well, and it's, I don't know if it's their system there in Lincoln Park and the Loop, or if it's my system here in the place that I'm in. Okay, so but it is working better, and so either that, or we can have a phone conversation as well. That works as well. But I think being able to share screens and get FaceTime also helps a lot. And I've been convinced of this. I've had teachers who've told me, look, you need to do this. You need to get, particularly when you're doing online teaching, you need to get face-to-face contact and have conversations with the folks that you're teaching. Y'all, right? So, final project proposals. Those are due next Wednesday at 6 p.m., February 26th. Yes. And then next week, again, last week, this week, next week. Next week, we're going to be taking a look at a couple of different things. These are pretty cool, actually. I sort of lumped these together for there's good reason for it, I guess, but one category is hyperspectral imaging. And hyperspectral imaging is maybe the next phase of digital imaging. And so, the cameras that you have in your phone, or even if you have an expensive digital camera, they probably image in 3 or 4 channels. So, good cameras will image in 4 channels, 4 parts of the spectrum, and they're typically discrete parts of the spectrum that are, there are little gaps between them, so they're discrete. And so you get data, and the data, maybe is 8-bit, maybe 12-bit in each channel, maybe even 16-bit in each channel, like Landsat is now. But in hyperspectral imaging, we get a continuous, I guess you'd call it a continuous set of channels that there are no gaps between them across the visible, near, and mid-infrared spectrum. And these channels are very narrow. And so a typical hyperspectral imaging system will image hundreds of channels across the range of the spectrum that is covered by, anywhere from 6 or 7 to 10 or so channels by the multispectral imaging systems that we work with, like Landsat, for instance. So Landsat is not hyperspectral. There are some hyperspectral systems in space. There's a very interesting project that we'll take a look at that is available actually in Earth Explorer. That's called Hyperion, and Hyperion was a sensor that was on the test satellite that went up in 2001 that was the test satellite. It's called EO1, the test satellite to try out the technologies that eventually were used on Landsat 8. So this is kind of how, how NASA does things sometimes, is they send up a test version of a sensor years before they actually put up the operational system that they're planning to use. So there actually was a test version of the OLI imager. It was called the Advanced Land Imager, or ALI, which is kind of interesting again. But that one went up in 2001. But the one we're interested in for this part of our class in week 8 is the Hyperion. So we'll be taking a look at that. And there are a couple of other hyperspectral imaging systems. There's one actually that they fly on the U2 aircraft. Still, they're flying a hyperspectral imager on the U2 aircraft. It's called Avirus or Avirus. I'm not sure exactly how that acronym is pronounced. And then next week we're also going to take a quick look and hopefully open your eyes to what's happening in terms of planetary imaging. Now, I don't mean imaging with a telescope. I'm talking about the imaging of planets, and there's a lot of different projects that are involved in imaging planets, everything from the moon, which is our sister planet, all the way out to Pluto now, and all the way into Mercury. Certainly, we actually have a new satellite that just went up in the past few weeks. That's going to give us some interesting images of the poles of Mercury, which is kind of an interesting place, and also the poles of the sun as well, which is an interesting place. But planetary imaging, this is how our solar system is going to be explored, and how discoveries are going to be made, and have already been made. Many discoveries that have been made by planetary remote sensing satellites. So using some of the technologies, the same technologies that we're becoming familiar with in this class, but using them on places like Saturn and the moons of Saturn, Jupiter and the moons of Jupiter, Mars. And Mars right now, it's going to happen in your lifetimes. There will be people on Mars. I'm not crazy about that idea, but I like the idea, I think, of robots on Mars, or of robotic devices, or devices to explore and to discover things about our solar system that maybe can tell us some things about our home here on Earth for the folks who live here. But again, planetary imaging, this is a really exciting field. There is a lot out there. There's a lot of data available. There's a lot of different sensors available. There's some really interesting and cool things going on in planetary imaging. So, this is what I'm going to run through some of this next week in our content in week 8. So, Remote Sensing 1, week 7.